Question number 12. Find the set of values of x which satisfy this inequality. So let's write question 12. We have 8 divided by x squared plus 1 is less than or equal to 9 divided by x. And the question says x is not equal to 0. This is merely because if x is 0, this entire inequality will become meaningless. Because imagine we have 0 here, so it doesn't have any meaning there. So now we have to get rid of the x in the denominator in order to solve this inequality. So what we are going to do here is we will multiply both sides by x squared. So if I multiply this by x squared and this by x squared, and when we have either an equation or an inequality, and we do the same action on both sides of equation or inequality, it keeps the equation or inequality balanced. So let's multiply x squared. So we have 8x squared divided by x squared plus 1 into x squared is x squared, and that is less than or equal to. Now from here the x in the denominator cancels out one of the x's, and I'm left with x to the power of 1, so 9x. Now this x squared and x squared also cancel. So on the left side I have 8 plus x squared is less than or equal to 9x. Rearranging, x squared plus 8 minus 9x. In order to find critical values, we equate to 0. Product is equal to negative. No, we need to rearrange before. X squared minus 9x plus 8 is equal to 0. So our product is positive 8. Sum is negative 9. So the numbers are minus 1 and minus 8. So we have x minus 1 into x minus 8 is equal to 0. Therefore, x is equal to 1 or x is equal to 8. So let's draw a graph to figure out the inequality. Since the question says we are looking for the y values less than, so this is like less than 0, we will look for the area below the x-axis. So this is 1 and 8. So x values will be greater than or equal to 1, less than or equal to 8. That answers question number 12. Moving on to question 13. Find the values of k for which kx squared plus 8x plus 5 is equal to 0 has real roots. So we have kx squared plus 8x plus 5 is equal to 0 has real roots. Now when we say it has real roots, it means its discriminant, which is b squared minus 4ac, is greater than or equal to 0. So let's find the discriminant. So we have a value k, b value 8, and c value 5. Therefore, the discriminant will be b squared minus 4 into a into c. And that should be greater than or equal to 0. So we have 64 minus 20k is greater than or equal to 0. Therefore, 64 is greater than 20k. Therefore, 64 divided by 20 is greater than k. So 64 divided by 20 is 3.2. 3.2 is greater than. In other words, k is less than or equal to 3.2. So that answers question number 13. Moving on to question number 14. Question 14 says you have equation 2x squared plus 4kx minus 5k, where k is a constant and has no real roots. So let's write the question. We have 2x squared plus 4kx minus 5k is equal to 0. Now when we say no real roots, that means b squared minus 4ac, or the discriminant is less than 0. Let's find the discriminant. A is 2, b is coefficient of x, which is 4k, and c is the constant, which is negative 5k. So b squared minus 4ac will be 4k, that's b squared, minus 4 into the a, which is 2, and into the c, which is minus 5k, and this should be less than 0. So that gives you 16k squared plus 4 5s are 20, 22s are 40k, and that should be less than 0. To find critical values, we equate this to 0. 8 is common and k also. So 8 2s are 16, 8 5s are 40. So critical values are 8k is equal to 0, 2k plus 5 is equal to 0, k is equal to 0 divided by 8, therefore k is equal to 0, and 2k is equal to negative 5, k is equal to negative 5 by 2. So let's sketch the quadratic curve. We have minus 5 by 2 and 0. Since the inequality is for value of y less than 0, value of y less than 0 is below the x-axis. So it's x values from minus 5 by 2 till 0. So x is greater than minus 5 by 2, less than 0. That answers question 14. Moving on to question number 15. So question 15 says sketch the graph of a y, which is x squared plus 2x minus 15, and we have another function gx or y is equal to 6 minus 2x. So we have y is equal to x squared plus 2x minus 15, and this is my f of x function. And I have another function which is g of x, and that is y is equal to 6 minus 2x. So since I have to find the coordinates of point of intersection, so the first thing that I can do is to solve them simultaneously. In order to solve them simultaneously, since I have y is equal to here and y is equal to, I can equate both of this, since both of them are equal to y's, and hence they will be solved simultaneously. X squared plus 2x minus 15 is equal to 6 minus 2x. So I have x squared plus 2x plus 2x. When this 2x goes to the left, it's negative, it becomes positive. And minus 15 minus 6 is equal to 0. That gives me x squared plus 4x minus 15 minus 6 gives me minus 21 is equal to 0. So now the product is negative 21. Sum is positive 4. So I have 7 3s are 21. 7 can be positive and 3 is negative. So my factors are x plus 7 and x minus 3 is equal to 0. X is equal to negative 7 and x is equal to 3. So the two graphs have intersection x coordinate minus 7 and 3. Now let's sketch the graphs. So this one is a quadratic curve. So it's going to be U-shaped. Okay, now to find the x-intercept of this graph, I will equate this to 0 to find its x-intercept. So x squared plus 2x minus 15 is equal to 0. Product is negative 15. Sum is 2. So 5 threes are. So I have x plus 5 into x minus 3 is equal to 0. Therefore, x is equal to negative 5 or x is equal to positive 3. So my x-intercepts for the quadratic curve is minus 5, 0. And here it's 3, 0. Let's draw the y-axis. It will be roughly here. And I can see that the y-intercept for the quadratic curve is minus 15. So this point here is my y-intercept, which is going to be 0, minus 15. Okay, now moving on with the sketch of the line, it's 6 minus 2x. It's a line with negative gradient, which means it will be inclined to this direction and has a y-intercept of 6. So let's sketch the line. So we'll do it with the green color. So let's assume that this is 6 here, since the y-intercept is 6. So, or we'll keep it a little lower. And the line also crosses through, because the two lines, the two graphs meet us at x is equal to 3. So which means my graph of the straight line and the graph of the curve both pass from here. That's why they have x is equal to 3 as their meeting point. So the two graphs meet here. So I'll make the line passing through 3. So now I need to extend the graph because it also intersects here. So the green sketch. So now the graphs intersect at 2 points, which we can clearly see are this point, which is, say for example, A, and this point B. Okay, so first what we did is we found the point x coordinate of the point of intersection of the two graphs. So one of the x coordinates is 3 and the other x coordinate is negative 7. So this is going to be negative 7. And since it says find the coordinates, so here the coordinates are 3 and 0, since this is on the x-axis. On the x-axis, y coordinates are always 0. So we need to find the y coordinate of the point B. We can use this equation here because this gives us y value. We can use this one also, but since this one is easier, we go for this. So y is equal to 6 minus 2x. So y is equal to 6 minus 2 into the x value, which is negative 7 here. So into negative 7, and therefore y is equal to 7 2s are 14, 14 plus 6 is 20. So 20. So that answers part A. We have got our intersection of the curves of the curve and the line at minus 7, 20 and 3, 0. Moving on to part C, write down the set of values of x for which fx is greater than gx. Now f of x is my curve and g of x is the straight line. So I want to find where fx is greater than gx, which means where the y values of the quadratic curve are greater than the y values of the line. So this is where the y value of the quadratic curve is greater than the y values of the line. Because if we take any point here and here, say for example, they'll have the same x coordinate, but the y values of the quadratic curve will be greater. So the y values of the quadratic curve are greater where it is above the x-axis. So let's shade this here. Also on the other side, I have my graph of the quadratic graph going up like this. And the line, straight line is below it. So if I take any x coordinate on the straight line and on the curve, the corresponding y values will be greater for the curve. So the y values of the curve are greater at this point. So writing the answer, let's write the answer for that. So for C we have, for C, so fx is greater than gx. So that is when x value is greater than 3. That is when x values are greater than 3. And when x values are less than -7. So when x values are less than -7. And that answers question number 15.